talking about matrices as a mathematical tool, and I briefly gave a short introduction to writing matrices and depicting their elements as a function of the rows and the columns and things like that. In this video, I want to talk about some special types of matrices that you have. So let's say you have a matrix. You have a matrix that has only one column. So let's say you have the matrix 2, 3, 4. So this matrix, let's represent it by A. A is of the order, there are three rows and just one column. So the order is 3 times 3 cross 1. And since this is just one column, the types of matrices that have just one column, they are called column matrices. Matrices, or a column matrix for this example. And you could have any number of rows, but as long as you have a single column, it's called a column matrix. And you could have the analog in the form of rows. So if you have a matrix which is just a row, it just has a single row and multiple columns. So let's say you just write 1, 2, 3, 4, 5. So this has 5 columns, and if you write that out, B has 5 columns but just one row. And in analogous to what we have done for column matrix, this is called a row matrix. So column matrix has one column and a row matrix has one row. Great. We can also specify another type of matrix that's very useful when we talk about linear equations further in the few next videos, and that will be square matrix. So remember, matrix being sort of a rectangle, you can make a rectangle into a square. How do you do that? So if you have a matrix that has 2 rows and 2 columns, so if you fill it out, so let's say you have x cubed cos x 1 root 2. This matrix has 2 rows and 2 columns, and since that has equal length and breadth, sort of, it's not a geometric figure, but still you can consider it being as having equal lengths and breadths, you call it as a square matrix. You could have a 3 by 3, that's a 3 by 3 square matrix. You could have a 4 by 4 matrix, that would be a 4 by 4 square matrix, and so on and so forth. You also have something called a diagonal matrix, and the diagonal matrix, as the name implies, it just has a diagonal. So if you have a 3 by 3 matrix, let's name it as D. So in the matrix D, you have 9 entries, 3 rows, 3 columns. And in here, within these 9 entries, just the diagonal, this diagonal, when we talk about the diagonal of the matrix, you're talking about the diagonal that originates from the upper left to the lower right, and that's called the diagonal. And for a diagonal matrix, only these entries can be non-zero, and all other entries here are just equal to 0. So 0, 0, 0, there is a 0, there is a 0, there is a 0. And you could put in any numbers here you want, so you could put in anything as per your wish. So there could be I, root 2, pi, and that's just a diagonal matrix. Oh, a word about diagonals though. If you want to write out an expression in terms of the small a notation that we were using in the last video, for diagonals, both the rows and the columns have to be equal. So For example, I lies on the first row and the first column. Root 2 lies on the second row as well as the second column. Pi lies in the third row as well as the third column. So for diagonal, the expression would be just AII, the same row and the same column. We also have something that's called a scalar matrix. A scalar matrix. Scalar matrix, and it's sort of an extension of diagonal matrix. So what you do is you still have the diagonal matrix, nothing changes about that. But instead of having different entries in the diagonal, you have all the same entries to be equal to a single number. So you put root 2, root 2, root 2 here, all of them are equal, all of the diagonal entries are equal, and it's called a scalar matrix. So in this case, D3 by 3 is a scalar matrix. You could have put in any number here. You could have put in I, you could have put in I, you could have put in 1, 1, 1, and it doesn't matter as long as you have a diagonal matrix, and the diagonal entries are equal to a single number. And just taking on from here, you see a matrix that just has zeros and ones. This scalar matrix, this scalar diagonal matrix, has a very special name to it. It's called the identity matrix. Identity matrix. And I would really not say much about the identity matrix, except for the fact that it is a scalar matrix that has all its diagonal entries at 1. And for this identity matrix, it sort of is like the number 1 for matrix algebra, but we will get to it in the later videos. For now, let's just make a few identity matrices. So if you want to create an identity matrix, you usually name it by the letter capital I for obvious reasons. And I 1 cross 1 is just equal to 1. I 2 cross 2 is equal to, well, just the diagonal entries are 1, except that all of them are 0. I 4 cross 4 is equal to 1, 1, 1, 1, and then all other entries become 0. And identity matrix only applies to square matrix. So we started with square matrix, we went to diagonal matrix, from diagonal matrix we went to scalar matrix, from scalar matrix we went to identity matrix. Really cool. Before ending this video, let's also talk about a matrix that's really trivial, though it comes to some use anyway, and it's called the zero matrix. The zero matrix. The zero matrix. And the zero matrix, as the name implies, has all its entries 0. All its entries 0. So it's not a big 0 like that, it's all the way, all the entries are just 0. So if you want to write, let's do a bit of mathematical notation. So A equals Aij, wherein Aij is just equal to 0 for all ij. That constitutes a zero matrix. So hopefully this video helps you recognize some special types of matrices. We'll continue our discussion about matrices in the next videos.